with just a regular HDMI.
Yeah.
Oh, you don't need it too good. Yeah, that's the best way then. It's just sometimes we've had a hard time. The input didn't always work. Yeah. Like, I forgot to do that earlier. I think that's the right one. Why is it on? Select a source. See, I always got confused by this.
I think you just select. Oh yeah, booth. Okay.
How do you select HDMI though? I always felt like there's something where we had to do that and then replug it in. We just plug this guy in and see if it grabs it. Of course, is the projector even projecting?
It doesn't sound like the projector is on. It's on.
Oh, there it is. Okay.
So that's the Apple TV. So if we go back, I think it'll work now.
We do this every time.
Yeah, and I don't ever know what.
So it is recognizing it, but sorry, I'm making your screen jump around. You might have to, I think, try playing with your resolution. If you get it lower, it might show up.
Do you know what resolution I should have it at?
I don't remember. Try just maybe like 800 by 600.
That small?
Absurd. Oh, there it goes.
Okay. That was 800.
I actually switched this
you switched
here
something?
to wall. So apparently this cable's going all the way through the booth into the wall. So I needed the wall thing, not the booth. So you might actually be able to go up higher.
Oh, it's the wall. Okay. Well,
You think that because it's in the booth, but yeah, once I switch to the wall, then there's two options: the VGA or the HDMI.
Is it all right if I ping everybody and let them know that we're streaming?
I'm fine with it. That way, people are like, "Well, you never told us you were streaming." Oh.
Okay. So, I was only half paying attention because I was enjoying my pizza. How long, who here's used Scala for more than 5 years? How about 3 years? Okay. 2 years? Okay, so it looks like everyone in here raised their hand by 2. So we all know what implicits are, and admittedly this presentation is aimed more toward the beginner/intermediate level of Scala developers, but I am confident that there are going to be things in here about implicits that you have at least tripped you up before, maybe forgot about, maybe even didn't know. So I hope that we all can learn something useful from this. It is posted on GitHub as well, GitHub pages. If you want to go back and watch go through the slides, I will share those slides to the Slack after this presentation. So my name is Stephen Rollins. I actually neglected to put my name on this slide. I am a software engineer at Lucid Software, which is where I learned to program with Scala. Before Scala, I did C++, and Java. Scala was my first exposure to functional programming, and it was a little weird at first, but I've really just fallen in love with it, which is why I've gotten into the habit of giving presentations at Lucid about Scala, helping to get other people on board with the language. Okay, what is an implicit? Let's start at the beginning, right? Key is a string, and why are we able to call arrow on it? And that's because implicitly under the hood, we're converting it to this class called arrow association, which is part of the Scala predef library. And it has an implicit def that will convert any value you want into an arrow association, which has a function available on it called -greater than. And so under the hood, this line right here is what everything looks like when you desugar it. You take away the nice infix syntax of the function call. That is what Scala compiler is spitting out. Implicits seem to be black magic, but they're really just syntactic sugar, and everything that they do follows certain rules and is supposed to make sense. And even though it might seem like magic, so implicits are also type safe. They have no runtime cost whatsoever. But if you're going to start making really heavy use of implicits and type craziness, then you might pay a little bit of a compile time penalty. What can be implicit? Vals and vars, defs, classes, objects, basically everything except for traits. I couldn't think of anything else that didn't fit in these categories. Basically anything can be implicit in Scala, which is both good and not all that helpful. You create an implicit by using the implicit keyword, and you also can create implicits by marking the final parameter list in a function as implicit, which will make all of those parameters available implicitly within the body of the function. Available implicitly, I'm talking about what we have as this implicit scope, that variables that are available are in scope in the current line of code, but have been marked as implicit. Are the compiler has a reference to them as part of the implicit scope, and when you need to resolve an implicit, it will look there. So where can they be used? The easiest example is implicit parameters. If you have a parameter list and you mark it as implicit, then that means that you can invoke the function without necessarily providing all of the implicit parameters, as long as there are some implicit variables in scope at the time that you call the function. It will use those instead. This is useful if you want to carry around some very heavy context objects that you need everywhere, but you don't necessarily want to have to explicitly pass around. It's also really useful for providing information about the objects that are coming in, which happens more if you're programming with generics and types. So with this example, I have a function say hello that takes an implicit string and says hello to that name, and I have an implicit string which has the value of Stephen. So when I invoke the function say hello with no parameter list, then it takes the implicit string and outputs hello Stephen. But if I provide a parameter list, I can explicitly override that. I can say hello Casey instead. Another use of implicits is to view an object as another type. It's kind of like polymorphism, but it's not supported by the type system. It's just going to call a function that converts a type from one object to one class to another. So here I have an implicit def, which converts an A to a B, and A wraps an int and a B wraps a string. And all it does is call toString on the number within the A and return a new B. And then I'm going to create an A, which is wrapping the value 5, a function which wants a B, which will just print out the value of the B, the string, and I'm going to call it with an A. This would normally be a compiler error, except we have declared our conversion function as implicit, which means the Scala is able to take our A, call this function, and use the result in place of the B that we were expecting. So we basically can view this A as though it was a B. This only works with implicit defs and implicit classes. Yeah.
How would this work with an implicit class?
With an implicit class, so I think that does my next slide have an implicit class? Yeah, it does. Okay. With an implicit class, what happens under the hood with an implicit class is that Scala creates the class and an implicit def at the same time. And so you are ultimately ending up using an implicit def. Yeah, I'll just stay on this slide since we're talking about implicit classes right now. So in this case, I could have done a function that takes a string and returns another string. Although in this particular case, because those types are the same, the compiler wouldn't invoke it. But if it was like an int to a string, actually no, that I think that it will still work. Like if you have an implicit, in this example here, this implicit class is making a new variable available that is not naturally on the string class. But if you have an implicit class, then I don't know. Perhaps I'm mistaken. Are you asking that question because you don't think that works?
No. I just had never seen it done with the class, so I was curious.
Yeah. To my knowledge, because of the way that implicit classes are implemented, it does create basically a companion function that is implicit that does this, converts your wrapped type into an instance of your class. And so if this had been an implicit class that was like an A to B converter, or even if B was an implicit class, right? Then I could use this the same way. But on that note, case classes cannot be implicit. So that's another thing that can't be implicit that I forgot to mention on the previous slide. So it wouldn't have worked in this example, but if I had rewritten it, I could have made it work with an implicit class. Okay, the other way that implicits are used is to fill in a missing property. To decorate or enhance an API is often a common way to do this, and it is used pretty heavily within the Scala library. It does a lot of this. So here I've defined an implicit class called smartString that takes a string and has a variable or has a function on it called thrice that will turn the string into a copy of itself repeated 3 times. And then I create a string and I want to print out my string.thrice. That would cause a type error because string does not have a variable or a function on it called, or a method on it called thrice. But because we can implicitly convert our string into a smart string, which does have a method called thrice, the compiler is able to implicitly convert this to a smart string and then invoke the thrice function. So the output is hello world repeated 3 times. Okay, where should I use implicits? This might be an area of some debate. One of the problems with implicits is that they can make your code a little bit opaque, but they also are really, really powerful and can enable you to do some cool things. Though one thing to remember is that implicits are really just syntactic sugar. If you don't want to use implicits, you can just do everything the verbose way, and that's also totally fine. So one way that you can do it is to, I say, enrich external APIs. Provide a function that is not normally available on a class, as in my previous example. One case that I use, Scala has instance of, which is, or as instance of, which will throw an exception if you try to convert a class illegally. Like here, I've tried to convert a date into a Boolean. So if I want to do it safely, perhaps in a more functional way, I want to use this function as optional instance of, which will allow me to maybe convert my date to a Boolean and get an optional Boolean, or if it fails, it'll just give me a none instead of throwing an exception. And I do that by creating an implicit class which takes an A of any type. In this invocation, A is a date, and then it defines a function called as optional instance of, or as opt instance of. And so now I can call that on dates, I can call that on strings, I can call that on some case class that I created, because A is an unbounded type, so I can call it on anything. Another way that you can do this is if you're using some third-party SDK and they have a function, or they lack some functionality, but you can sort of recreate that functionality using methods that they already expose. If you want to, you can sort of decorate those external classes by creating wrapper classes for them, creating the function you actually want on that wrapper class, and now it appears as though their SDK exposes the function that you wanted. Another way that you can use implicits is to reduce boilerplate, again with context variables. In Scala, whenever you create something that happens asynchronously, you must provide an execution context which defines how the threads are created, what thread pool you have to draw from, things like that. Really, really important to have, but really not all that fun to have to pass around all over the place, depending on if you have like a really, really exhaustive name for it or something like that. So if you make it implicit, then all of a sudden you can just leave that parameter list out, and everything's okay. You also have to be careful that you're still being smart with that context object. Like in this particular case, if you want to have multiple thread pools that manage different types of resources or different types of asynchronous operations or whatever, and you use one of them implicitly, and another developer comes around who doesn't really know that this is what Scala does, and that there are reasons that we have different execution contexts, and they'll just write a future and it'll just compile and work, and maybe they're using the wrong thread pool. So again, that's the warning to not do it so much that it becomes obscure and opaque and hard for other developers to follow. Another and probably the most powerful use of implicits is type classes, which are common in other functional programming languages. Basically, it allows you to say, I have these classes that behave as, in this case, they behave as something that can be turned into JSON. And so even though string and double, which are defined very much outside of my control as part of the Scala language, I can make them appear to almost inherit from a class that has a toJSON property. But all I've really done is created a class that I have a JSONable of type string, which knows how to convert strings to JSON, and a JSONable of type double, which knows how to convert doubles to JSON. And then my function that'll actually convert my values to JSON that takes an object of type T, an unbounded type parameter, but then it also takes an implicit JSONable converter that knows how to convert T to JSON. So now it is valid for me to convert a string to JSON. It's valid for me to convert a double to JSON, but because I did not define a file JSONable, it is not valid for me to try to convert a file to JSON. And so it's almost as though I had defined a type hierarchy, and that these guys are of some type that can be converted to JSON. Are there any questions about these uses of implicits? Okay, where should I avoid using implicits? Please, even though I'm using it in my example, don't make implicits of a really, really common type. If you need an implicit Boolean, maybe it's better to create a case class which takes only a Boolean as a parameter and has a really, really intuitive name that is clear what the context of this Boolean is for. And then that way, if I have an implicit of this type of flag or whatever in scope, then I know what that value is for. And I'm not likely to have ambiguous implicits because I have a whole bunch of Booleans in my implicit scope or something like that. That don't use really, really common types. It's better to wrap them in something that's more intuitive. So use specialized and unique types that will avoid collisions, avoid polluting the implicit scope, avoid the wrong implicit being used for the wrong time. And then also be specific. If you can use a child class instead of a superclass as the type of your implicit, then you should probably err on the side of doing that. Another thing to do, forgive the lucid code example here, but don't nest your implicits. What I mean by that is we have here an implicit def that takes an implicit parameter. This is so hard for the non-Scala developers to follow. They get in here, and this really does feel like black magic. We use the Play framework, and the Play framework gives you this request object that has all the headers and everything, including our authentication headers. And so we have these helpers that facilitate communication between services. In this case, this is a helper that facilitates talking to our service that knows about users and accounts. And we want to continue to propagate the authentication of whoever was talking to me should be the user who's talking to the user service. I should be having the same permissions as that user. And so we take this implicit request header, which is Play's request object, and tie this in with our HTTP request. And so now all of a sudden, when you make a .get request to the user service, it takes an implicit request modifier that knows how to apply the authentication headers, and it does so without you knowing, just because you happen to be carrying around this context variable, this implicit request object, everywhere you go. And so now if the request object is missing and things fail and nobody knows why, or it just authenticates as one user, but that's not the user you wanted to authenticate it as, or something. It's this pattern has really caused a lot of problems. So don't do it. It's very hard to follow. You normally can't combine implicits, but you can if you're doing an implicit function that takes an implicit parameter. So, and then finally, implicits are not an excuse for bad style. Again, don't make your code opaque or terse to the point of not being able to understand it. Don't require huge objects. Again, I'm referencing a Lucid thing here, but like the request header object from the example before, which has a lot of contextual information, probably very little of which I need at any given time. And if you start passing these big objects around, then you've made it so that all of your code is A, tied to the framework that you're using, and B, if you want to have something that just like reads a single query string parameter, just pass in the query string parameter, don't pass in the entire request. That's just good practice in general, and implicits can make it kind of easy to start passing around big context objects that are bigger than what you need. So don't use implicits as an excuse to carry around more context than you need. Okay, so a couple of advanced implicit topics. Summoning implicits from the netherworld. I mentioned that there is an implicit scope, and if you want to be able to find out what variable is going to be used at any given time, so here I have an implicit string, and then if I ever need an implicit string and I want to know what implicit is going to be used, or if I want to pull it out of the implicit scope and make it bring it into the explicit scope, we have this function called implicitly, which is provided by Scala's predef library. Implicitly is defined as a function that it takes a generic type t and an implicit variable of type t and then just returns it. So this allows you to pull that value out. This is useful, for example, if you want to partially provide some parameters in an implicit parameter list. It's all or nothing. It's the presence of the parentheses decides whether or not the compiler is going to resolve that parameter list implicitly or not. If you want to provide any of those values, you must provide all of them. The Scala compiler will not implicitly provide the ones you don't say. So if you have an implicit parameter list that takes 3 parameters, you want to override one of them, but you don't want to override the other 2, and you don't know what value Scala is implicitly using, you can just use the implicitly functions. You can say implicitly, comma, the value you want, comma, implicitly. Everything will work totally fine. And Scala will figure out for you, like here, it's using the context. It knows that A is of type string, and so therefore it resolves T to be of type string. So I don't have to annotate the type, although here I do because Scala has no idea what type I want there. So it'll be able to imply the type that you want if you're using it in a parameter list. And then context bounds and view bounds. Again, this is like making an object appear to be of a type that other than what it is, because you have a function that can convert it to that other type. These are both syntactic sugar on top of the syntactic sugar of implicits. So here I have a function called toJSON, which takes a type parameter of type t, JSONable, which desugars to what we saw on the JSONable example, where we have t, we take a t, and then it adds this implicit parameter list, which takes a JSONable of type t. That is all that this colon does. It provides the implicit parameter list for you, and then makes it available to you. It guarantees that within the body of this function, you have a t that has an implicit JSONable available to it. So because I am wanting to actually call a function on it, I'm using implicitly again to summon it. But if you want to call other functions that need this t as a parameter, as an implicit parameter, then you won't have to pull it out like I did. The other one is a view bounds, which is the %greater symbol. So I've got some function here, sort, which takes a t, which can be viewed as, or has a view bound of ordered sub t, takes 2 t's and then returns t1 is less than t2. So t, because we know absolutely nothing about t, it can be any type. we don't know that it has a less than function on it. But when we desugar this type bound, we add an extra implicit parameter list that says you can't call this function with a type that does not have a t to ordered of t function available implicitly. So our t must be able to be wrapped and turned into an ordered of t. And what that will do is any functions that are available as a result of wrapping this object and turning it into an ordered of t are available within the function. So in this case, ordered again is a predef function, a predef class available through Scala that knows how to say less than, greater than, equal. So even though I know nothing about t, I do know that t can be turned into an object that knows how to compare itself to another t. So this is a good example of how implicit functions and viewing an object as another type can enable you to program in a generic way, but still be type safe.
So that implicit, the EV, it doesn't actually use that implicit.
It does.
Oh, it does use it?
So again, less than is not a function on class t, because we know t is any val. We know nothing about it. So when I try to say t1 less than t2, that is a type error. But before we get our type error, Scala says, is there anything I can implicitly do to make this t be a function that has a less than, or be a class that has a less than function on it? And we have one right here. We have an implicit function that will convert our t into an ordered of t.
So if you just sugar this even more, I guess you'd have T1 being passed to EV and T2 being passed to EV.
Just T1. Yeah, it would desugar to, we call EV with T1 as the parameter, and then we call the less than function on that and pass it T2 as its single argument. Yeah. Yeah, any other questions? Yes?
I heard that the bounds are deprecated.
I don't know.
Yeah, I was just trying to look up the page for it. It looks like there's this issues.scala.org deprecation warning for view bounds in some version of Scala, I guess.
Okay, and does it say anything about what version it's deprecated in?
It's just that they believe that context bounds provides, it's just for simplification.
Uh-huh.
You can do everything you can do with a view bound.
Yeah, and you can see how similar they are, right? Like this is returning a class and this is returning a function. Yeah, they're very, very similar. So I would believe that I haven't seen anything about view bounds being deprecated, but it wouldn't cripple anything. Maybe it's a dotty thing. I definitely know this is an example of one of the things that makes Scala hard. Like, how do you Google search this? You know, you're like, I don't know anything about Scala. I just ran into this type parameter that uses % greater than. What the heck does that mean? So it certainly can. If you want to be a Scala wizard, you can make use of these things, but you might not make your coworkers very happy. Okay, so this is the really cool stuff, all right? I want to know, how do I resolve implicits? I want to be a compiler for a second and say, I'm using an implicit right here. Where am I going to look? There are two places that Scala looks, two tiers of places that Scala looks. The first one is I'm looking for an implicit value available within the current block scope, or within the current implicit scope. It's just available right now. It's been imported somehow. It's been defined locally. It's available to me because I inherit from a class that defines it. Anything like that. That's number one. And then number two is an implicit value made available on a companion object that is relevant in the current implicit conversion I'm trying to perform. So number one always takes priority over number two. But if there's more than one implicit that fits within one of these two tiers, within the higher available tier, then it will throw an exception and say, it's too ambiguous, I don't know. So if you have one that is available, like if you say implicit def, here's the function I want, and then you also have 20 applicable implicit conversions on a companion object, it'll use the one that's defined locally. They won't conflict. But if you were to delete that line of code, then you would get all kinds of ambiguity errors saying that, like, there's a bunch of conversions available to me, I don't know which one you want me to use. Did you have a question, or did I answer?
Available landing, just to clarify, does it matter what the name is?
Yes.
It doesn't say
No, I am.
must be referenceable right here. But
No, the name is important because you can shadow your implicit variables by naming another variable the same thing, and all of a sudden your implicit doesn't work. And that has bit me before.
the name of the variable that is that type can affect whether it gets.
The name of the implicit variable. So for example, you've defined an implicit conversion function from type A to type B, and then you've also defined explicitly in the current scope some other variable that shares the same name. And then later on, you want to convert an A to a B, and you are counting on the compiler finding the implicit function that you've imported or have available to you through inheritance or a different scope or something like that. It won't find it because you have shadowed that variable in a closer scope to where the code is running. So that is why I specifically say name, and I think I covered that particular gotcha later on. But that is something just to be aware of. And I also cover how you can figure out that that's what's happening. But you'll get weird errors. It'll just say that there's no implicit available, or it'll give you a type error or something like that, and it won't be very helpful. So, okay, going through these tiers of implicit resolution. So this example I'm going to be using a lot of is we're going to have a function called foo, which takes an integer and does something with it, prints it out, whatever. So in this case, there are no implicits. I'm calling foo. I have bad indentation, I'm sorry. And I've defined some integer called useMe. I invoke foo with useMe, and the output is 5. So I can make it so that foo takes an implicit integer, and then I can define an implicit val useMe right in the same block scope as where I'm going to invoke the foo function. So within the scope of run, things are fine. I can call foo. I don't have to provide the implicit parameter list because Scala will do that for me, and the output is 5. If I were to call foo down here outside of run, I would get an error because it would say it can't find the implicit. Here, on the other hand, I've now defined foo. I've now defined the implicit outside of the run scope, outside of the run function, and it's still available to me. Here I have a helper object which has an implicit function that will convert an integer to a string. And then I import that function. And then I've now changed foo so that it accepts an implicit string. I call foo with an implicit string. That's not significant. The fact that it's implicit isn't significant. I invoke foo with an integer. That would give me a type error, but we have imported a function that can convert integers to strings, and now we can invoke foo and everything is good. If I did not explicitly provide the 5 here, if I just had an integer variable called useMe that's value was 5, and then I try to call foo and let it depend on the implicits, because there is no implicit string available to me, it will fail. It will not look for an implicit integer that it convert to a string implicitly. It won't chain the implicits like that. I have to, which is why here I have to explicitly provide the 5 and the parameter list. One that's available through inheritance. So now I have a trait which has an implicit favorite number, another class that extends A, and has a function called print favorite number that takes an implicit number and will print it out. And then I invoke that function as part of the constructor. Nowhere in class B do we have an implicit number available, but because we extend trait A, we have it available through inheritance. And so now I can construct a new B, and the output will be my favorite number is 42. Any questions about those kinds of implicit resolutions? Okay, so the lower priority, the second tier of implicits, is when you have implicits on companion objects. So we're going to step through these one at a time. The first one is the source companion object. So if I have a class of one type, and I'm calling a function that expects a class of the other type. It's this first type that we're talking about now. So I have a class called superinteger and a companion object that knows how to convert superintegers into boring integers. A superinteger just wraps an int. And then a function foo that takes an int and prints it out, and I create a new superinteger and call foo with my superinteger. The first thing Scala is going to do is it's going to say, you've given me the wrong type. I'm going to look for an implicit function that converts a super integer into an int. And it doesn't find one. So then it's going to look on the super integer companion object for an implicit function that converts to a normal integer. And it finds it, and it uses it, and everything is good. It works the other way as well. It works on the object you're trying to convert to. So again, I have a super integer. I now have a second class called superstring, and on superstring, I have created my implicit conversion that turns my super integer into a superstring. I invoke foo with a super integer, and it says, you're not a superstring. I'm going to look for an implicit conversion. Doesn't find one using the first set of rules, but it looks on the superstring class, finds a function that does what it wants, and uses that one. If I were to have defined a class on both the string companion object and the integer companion object, then it would fail because it wouldn't know which one to use. Okay, this one is really a little bit convoluted. Implicits on the companion object of inner types. So I have super integer, a companion object which defines an implicit ordering of super integer. And again, an ordering knows how to say, I'm greater than you, I'm less than you, I'm equal to you. I have an unsorted sequence of super integers of various numbers, and I want to call sorted on them. Sorted is a function available to the sequence class that takes an implicit ordering of the type that the sequence contains. So my sequence contains a bunch of super integers, and it's going to say, I don't have an implicit ordering of super integer available to me. So I'm going to look on the sequence class, I'm going to look on the ordering class, I'm going to look on the super integer class, because it is the inner type in this equation. And it will find it on the super integer class. So because of that, everything works just fine. Any questions about any of those, that second set of implicit resolution rules? Yes?
So when it searches for the companion object of super integer, is it looking because it's a inner type of ordering or an inner type of sequence?
I don't know. In this case, it is an inner type of both. I'm not actually certain. It probably looks in both places. Although I'm not sure you can convert from a sequence of one type to an ordering of another type implicitly. That might not be able to be done on the companion class. So that's a good question. I haven't looked into that deeply enough. Anything else? Okay, some limitations of implicits. I've already mentioned this a few times. Implicit chaining is not allowed. So I have A, B, and C. Classes B and C are both implicit classes, which means if I ever need a C and have a B, then I've got a C. And if I ever need a B but I have an A, then I've got a B. It'll just implicitly convert it for me. Everything's cool. But if I have an A and I need a C, things don't work. So A has a foo function on it just naturally as part of the A class, so I can say a.foo and everything's cool. B has a bar function on it, and I can convert A's to B's, so I can say a.bar and everything's cool. But A and B, neither one of them have a baz function on them. C does, but I can't implicitly convert an A directly to a C. If I could make two hops, I could, but that's not allowed. We should be grateful that it's not allowed because it would really make things convoluted and it would slow the compiler down a lot. So that is a type error, and I can explicitly convert my A to a B and call baz on it, or I can explicitly do the whole way and call baz on it. Ambiguity issues. So here I have an implicit conversion that I have imported and an implicit conversion that I have defined locally, and then I want to convert my integer into a string so that I can invoke the foo function. That will throw an error because I have two implicits available to me in the same scope. So watch out for those. And then I mentioned this already, variable shadowing. I have an implicit variable called useMe, and I want to call foo, which takes an implicit int. Everything would be fine, except in a higher scope than where useMe is defined, I have defined a different useMe. It doesn't matter that they're the same type. What matters is that they're the same name. And because of this, I have now masked and shadowed my access to the useMe that is outside of the run function. I mean, that would be true even if I tried to reference useMe explicitly, right? It's the same kind of problem. Because this relies on desugaring, it would desugar to use the useMe name, and it can't because that's not implicit anymore. Some final tips. If you ever have weird implicit errors, then you can first try to explicitly provide the name that you want. If you have a conversion that's just not happening, you can go and track down the implicit conversion function that you think is being used, write it out by name, see what errors get thrown. You will probably have some kind of a type error if you do that. And that will help you figure out why your implicit is not being used for you. Because Scala is helpful and will not throw a type error on every failed implicit attempt. It will only tell you that there were no available implicits, or that you can't use an A in place of a B because your function that converts your A's to B's is not available right now, and it's not going to tell you that. So, if you use IntelliJ or some other IDE, IntelliJ in particular will underline places where a function is made available implicitly, or a parameter is being converted to a different type implicitly, so you can at least identify by sight that an implicit conversion is happening. Your third step is to review the resolution rules and go through them manually, look at what's being imported, and see if there's something there, see if there's something on a companion object that is available or should be being used, or if you're wondering what is being used, you go look there and see what the sources are. Look at the parent classes. As a little side note, I like to use this because I don't use an IDE, and so I do sometimes have to do my implicit resolution manually. I like to make sure my imports are as explicit as possible. I avoid using wildcard imports because it makes it really hard to track down. If you're looking for an implicit yourself and there's like 10 different imports that all use wildcard, you don't want to have to go and look through all those packages and try and find something that's just exhausting. And then your final option, which is only available in a reasonable sense if you are using a small code base, is to run the Scala compiler and tell it to stop at the typer phase, which is what -x print:typer does. That will spit out the fully desugared code. It's not very pretty to look at, but you can see what name of implicit value it's using, and even the fully qualified class names and stuff like that. So if an implicit is happening and you don't know what's being used, you can turn to the Scala compiler itself and ask. Okay, that's all I have. Any questions?
The general question.
Yeah.
I guess. So I was talking to some coworkers earlier about implicits, and one of them spoke up and said, "I hate implicits."
You hate implicits.
Because it feels like black magic. Obviously, that's true in a lot of cases because they've used some kind of past. What do you prefer, and what does the group use to try and? Because I love them when they're used correctly.
Mm-hmm.
What do you do to try? You mentioned the implicit or the imports. Make those explicit as possible. Make the imports. Make sure that it's obvious where they're trying to go. What are there any other tricks to try and help others when you want to use a code base and there might be those that are resistant?
Okay, so the question is, what do we do to try and get more people on board with using implicits, just in general? Yeah, I definitely think that you can try and set standards and say, don't use them in the wrong way. Because I think that what really gives implicits a bad rep is when people take them too far. It's just like how Scala allows you to have symbolic operators, which is cool, but then if you have a library like dispatch, it becomes really, really opaque. You can take a good thing and you can take it too far. So I think a lot of it would be educating your developers on how to use them correctly, and also educating your developers on these are the primary implicits that we use. That's why I had so many lucid examples that I snuck into my presentations, because when I gave this to my coworkers, I knew a lot of the pain points that they had. And so I was wanting to say, like, let me show you what implicits you're normally going to run into in your 1 day a week that you might look at our server code, and this is where you're going to look for things. This is how we use things and why, so that they are a little bit less mystified when they get into the code. And then I think the third thing is just remember that implicits are a tool, and just because you have a hammer doesn't necessarily mean everything is a nail. And so if you're going to be doing some really cool type class stuff and some more type stuff, is really where implicits become awesome, and where you can show somebody the version with implicits and without implicits and how ugly the version without implicits becomes. So if you're using it for cool stuff like that, then people, I think, would appreciate a little bit more. An example that comes to mind is the Play framework, specifically the JSON library in the Play framework, which I really, really like. But they allow you to define a reads object, which says, I'm going to turn a JSON object into this concrete type that I want, and then a writes object, which goes the other way. And then those are available implicitly. And now developers don't need to think about, you can just say .to.json or JSON.parse and provide it some type, and they don't need to think about it. And I think that helps people to appreciate a little bit more the power of implicits and how they do make their lives easier. But I'll open the table to anybody else if there are any other thoughts about how to make implicits more available to coworkers and stuff. Yeah.
Would it be a fair characterization to say that implicits reduce developer typing fingers?
They do reduce typing, and so does like not having to explicitly state the type of variables and stuff like that, right? Like, I think that's one of the cool things about Scala, is it can make things a little bit more succinct as opposed to terse, as long as it's making it more clear instead of less. Yeah.
So one thing that I think helps making implicits easier to understand is making sure that your implicits are defining the most specific scopes that they can be. For example, like if you have a method that uses a specific execution context, you should put the implicit in that method, not in the moving class, because then if someone adds an additional method, they're going to have to use the wrong implicit.
Yeah, and I think that's a great example. And I did briefly touch on that when I talked about using implicits as context objects, but to make them as close to the point of friction as possible, the point where you're actually going to use it, which benefits you both because it avoids using the implicit in the wrong place, and it makes it easier to look up and see where the implicit is. If you can't have it in the actual function, then maybe you can at least have it on the class, and it's still easier to find if it's like a private variable on the class that is implicit.
I find it easier to think of examples where implicits are used well and where they're awesome, and I can't think of any cases where. So there are lots of ways to use a lot of things that we can make confusing code, but I wish I had an example of a way that implicits made code more confusing right now, so I would know what people are finding problematic in that way.
So do you think that people think implicits always make things more confusing just across the board?
What I'm hearing is that people new to it go like, sounds all magical and I don't like it, and you're confusing me with your Scala-ese. And I don't know if it's just that they're like so new to Scala that it would take them a minute to understand and accept this, and they haven't gotten past that minute, or if there are actually things that some people are doing with implicits that are by design more confusing than the examples I can pick out.
Well, I could certainly think of some examples where implicits make things easier. And I mean, I started with the arrow function, right, which definitely makes things easier. I don't want to have to convert all of my types into some arrow association class, right? As far as things that make them harder, the first one that comes to my mind is like that double implicit example that I gave, where I have an implicit function that takes an implicit parameter. That really has caused a lot of problems for developers not familiar with Scala. And it's made people, it is a part of sort of a revamped library that we've provided for communicating between services, and it's made a lot of developers a little bit shy away from using that new library because that one aspect of it is so opaque.
Implicit parameters within the implicit.
Yes.
Case where you see that it's one level too deep for people to easily wrap their head around.
Yeah, and I would definitely try to avoid doing that if you could. Yeah.
I thought it was used in a very nifty way in a Scala test when you do a Selenium-based testing in that the WebDriver instance that you're using is defined within one of the traits that you add, and that is an implicit then used elsewhere. It saves you from having to frequently reference the WebDriver,
Like for interacting with elements on the page or stuff?
Like some Java code, JUnit tests that they used, Selenium, they used it with WebDriver all over the place.
Mhm.
Make your own methods that need to do something. You need to pass a WebDriver into them as parameters.
In our Selenium test,
we
we've
make constant reference to this thing that's like that does feel implied. It's like, well, yeah, it's browser. We know what browser it is. Come on, it's just magic, and it just feels more magical, more easy with the way that we make it available for
it makes the compiler feel a little smarter, a little bit more capable. Like you don't have to hold its hand quite as much. Are there any other just general questions or comments about implicits or even what we've been talking
I
about?
was just going to comment. I think you're asking about like an example of a place where implicits is hard. So you're talking about having this WebDriver provided through the implicit code. But for someone who isn't familiar with the code, like if you got this posted online and they went and copied that code, it's not going to compile unless you're also including all your imports, because presumably you're, in a lot of cases the implicit is resolved by including an import, and a lot of times code posted online omits your import statements.
So including the imports may be more necessary for in dealing with sharing Scala.
I think that would, maybe
especially
moving the imports for implicits down into the class or into the methods of using those implicits.
Any other questions or thoughts? All right, that is all I have.
Thanks.
Oh, did I not start my broadcast? Look at that, I didn't start.